Alright, yes, our first one is AAS, which is angle, angle, side. If two pairs of corresponding angles in a non-included side are congruent, then the two triangles are congruent. So look at that. Again, it is AAS, not ASS or SSA. Remember, we don't want to be a donkey, so it still applies. It is AAS. So you have two angles that are congruent and then a side. Okay, so you have angle, angle, side. Or side, angle, angle. Okay, ASA, what do you think that stands for? What is it? Angle, side, angle.
How do you know which way to, go? Can't you do angle,
Hold on.
side?
Chris,
Yeah.
are you hearing what Kinley's asking?
No.
Okay, stop talking. Go ahead, Kinley.
For the first one, how do you know it doesn't go the other way?
It could have gone the other way, like, I could have had this angle, and then these. I gave you one example of what it could look like. Okay, angle, side, angle. If two pairs of corresponding angles in the included side are congruent, then the two triangles are congruent. So let's say I have this angle and this angle, those are congruent. These two sides are congruent. Then I have these angles also congruent. So it's angle, side, angle. Could have also been angle, side, angle. Could have been angle, side, angle. I just gave one example. Okay, so what were the three that you learned last time? Hypotenuse leg. Side, side, side. And side, angle, side. And we're adding two more. So you have hypotenuse leg, side, 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 angle, side, AAS, and ASA. Okay, those are the five that you are working with. Okay, apart from hypotenuse leg, all the rest of them have to have three corresponding parts. Okay, so make sure you don't start confusing it with the similarity theorems. Alright, examples. In each example, answer each of the following questions. State the congruent parts, how the triangles are congruent, and state the congruence. Okay, so for number one, what do we know is congruent so far? The two angles. How do we name those angles? SPR is congruent to what? QPR. Okay, what's another congruent angle? Congruent pair of angles. SRP is congruent to what? QRP. So we have these two angles and our 90-degree angles. What else is congruent? Is this reducing all these? Well done. PR is congruent to PR. What property is that? Reflexive. Very good. Okay, so we have this angle, this side, and our 90-degree angles. So how would the triangles be congruent? All at once, please. How would the triangles be congruent? Angle, side, angle. Okay, so when we name our congruent statement, which a lot of you did not do on your skills check last class, your congruent statement, it's very important how you organize your points, okay? Whereas before we didn't necessarily put a lot of emphasis on how we named our triangles, it is very important now that you put your points in corresponding order, okay? So what would be your your congruent statement? Triangle SPR. QPR. Very good. Okay. So remember, when you're proving that triangles are congruent, okay, you have got to name them right. So SP corresponds with QP. I don't know why everybody turned their paper when I was still talking about a problem, but it's okay. PR corresponds with PR. SR corresponds with QR. Okay, so you have got to put them in the proper order, because SP is equal to QP, PR is equal to PR, and SR is equal to QR. So you have got to pay attention to how you are naming your triangles. Those of you that did do your congruent statement on your skills check, I think most of you did pretty good. Alright. Continue on. Number 2. What do we know is congruent? Tell me what's congruent. VX is congruent to XZ. What else? Angle WVX is congruent to YZX. Okay, so we have this side so far, this side, this angle, and this angle. What else is congruent? WXZ is congruent to YXZ. There's a lot of side conversations going on, and I'm not sure why. Okay, so our vertical angles are congruent always. Okay, so letter B, Chris Park. Why would the triangles be congruent? Angle, side, angle. Very good. Ishmael, give me a congruency statement. Try. Triangle. WVX is congruent to triangle. YZX. Very good. Okay, remember that there's more than one way to order those points, but you just have to make sure that they still correspond. Okay, so you could have said WXV is congruent to YXZ. Okay, so there's more than one way to name it, just make sure those parts correspond. Okay, number 3. Courtney, give me something that's congruent.
Angle A, angle B.
Okay, name them with 3 points. So angle
ABC is congruent to angle EFG.
Very good. ABC is congruent to EFG. Somebody give me something else. BC is congruent to FG. And somebody give me the last one.
Angle CAB is congruent to angle GEF.
Very good. CAB is congruent to GEF. Okay. So letter B, Hannah, what proves them congruent? Not angle, side angle. Angle, angle, side. So start at one point and go around and like verbalize to yourself what you have. Because if it was angle, side, angle, it would have to be this side that was congruent. Okay, we have angle, angle, side, or side, angle, angle. Fernanda, give me a congruency statement.
Triangle ABC is congruent to triangle EFG.
Very good. Those ones are easier to name when they're having the same orientation. Alright, example 4. Which postulate, if any, should be used to show that the angles are congruent? With your table, or by yourself, however you want to do it, challenge yourself and see if you can do A, B, and C. going to give you like 90 seconds. It shouldn't take you that long.
I get distracted.
Alright, Madison, letter A, what'd you put? Angle, side, angle, do we agree with her?
Yeah.
Awesome. Emma, what'd you put for letter B? Angle, side, angle, very good. So they share this common side, so you have angle, side, angle. And letter C, Katie. Angle, angle, angle. Is that a theorem that we have discussed?
No.
When did we use angle, angle?
Never.
When did we use angle, angle?
A long time ago.
A long time ago when we were proving that triangles are similar. What's the definition of similar triangles? Angles are congruent and sides are proportional. What's the definition of congruent triangles?
They're all congruent.
They're the same, which means their angles are and their sides are congruent. So the difference there is similar are sides are proportional, angles are congruent. Congruent is sides are congruent and angles are congruent. So notice that in both triangles, the angles stay congruent. So you cannot prove congruent triangles just based off AA. Okay, or in this case she said AAA. Okay, you would have to have at least one of the sides, okay, in order to prove that they are congruent. So AA is not one, therefore they're not congruent. Okay, AA is used only to prove that triangles are similar. So AA proves triangles are similar. Alright. Congruent triangles. So example 5. If triangle cat is congruent to triangle dog, list all the congruencies. Shh, Chris. So triangle C would be congruent to what? Or sorry, not triangle, angle. Angle D. Angle A would be congruent to O. T would be congruent to G. Y'all, I promise you there's nothing funny about triangle cat and triangle dog. Okay? Shh, drop it. AC would be congruent to OD. AT would be congruent to OG. And CT would be congruent to DG. I feel a new seating chart in the near future, because y'all cannot get it together. Okay, so that was review from last time. I believe we did that in our notes last time. Okay, so we're going to go back up to the top, congruent triangles. Okay, congruent triangles we talked about just a bit ago is a triangle where all the corresponding angles and sides are congruent. a triangle with all corresponding angles and sides congruent. Okay, now I want to introduce this idea of CPCTC, okay, and it stands for corresponding parts of congruent triangles are congruent. Okay, so in a proof, rather than write corresponding parts of congruent triangles are congruent, we call it CPCTC. So we just take the first letter. If you were to write that out, I wouldn't count off for it, but it's just shorter and quicker to write CPCTC. Okay, so that tells you that once you prove that triangles are congruent, okay, then all of their angles are congruent and all of their sides. So remember on our proof when we did similar triangles, once we proved the triangles were similar, we could say that any set of corresponding sides were proportional because definition of similar triangles. This would be the same thing. After you prove that triangle cat is similar to triangle dog, you would say that angle A is congruent to angle O, and that would be because of CPCTC. Okay, so it's that last little extra step. Okay, so we're going to practice in a second. But how many congruencies does it take for us to show that two triangles are congruent? 3. How many additional congruencies can we deduce after that? 3. Because there's 3 sides and 3 angles, so a total of 6, but you have to start with at least 3. And this would be because of CPCTC. Chris.
I wasn't even talking. I actually wasn't, I swear.
You're about to get a clipboard and sit on the floor right by me. No. Alright, here we go. Proof. RZ bisects TRS and angle 3 is congruent to angle 4. So, first steps are given, right? RZ bisects TRS and angle 3 is congruent to angle 4. So I'm going to mark my image. If RZ bisects TRS, what does that tell us about 1 and 2? They're congruent, and then it's told us 3 and 4 are congruent. Oh, sorry. Well, hopefully y'all know how to mark congruent angles, right? Yeah. Okay, just checking. Alright. So we don't know that those are right angles, so I made them arcs, but at first I made them right angles. So, statement number 2, what are we going to write? Angle 1 is congruent to angle 2. Why? Definition of angle bisector. Very good. Okay, what else? Very good. RZ is congruent to RZ, and why is that? Reflexive property. Step 4, what do we got? So you know that it's going to be angle side angle. Okay, but what needs to go over here? A congruent statement. Okay, what is our congruent statement? So SZR, this is how Carson wants to say it, is congruent to triangle TZR, you said? Very good. And you can double check, does SZ correspond to TZ? Yes. Does ZR correspond to ZR? SR correspond to TR? Yes. So we know we named it right. Then what would be my next step?
Angle S is congruent to angle T.
Angle S is congruent to angle T, and why, Kinley? CCCTC. So just know it's C, P, every other letter is a C. C, P, C, T, C. And then the two other letters are PT, so like part-time. C, P, C, T, C. I don't know. Think of some way to remember it. If you don't want to use part-time, I don't know what you want to use. Physical therapy. Sweet. Whatever makes you remember it. Alright, so that was one proof. Not that bad, right? The only step that was tricky is maybe saying that angle 1 and angle 2 are congruent because of angle bisector. Because you might forget that just because you think that maybe that's implied in your given. Okay? That would be the only thing that I think would throw you off. Alright. Given AB, sweet, B is supposed to be down here. AB bisects CD, and angle C is congruent to angle D. So my givens, AB bisects CD, and angle C is congruent to angle D. Oh, this should be given. So what's my next step? Or give me a step. You want to say vertical angle? So angle what? AMC is congruent to DMB because of vertical angles. We already know that C and D are equal. Now we know these are equal. You're not. AM what? So AB bisects CD. CM what? Very good. CM is congruent to MD, and why is that? Definition of segment bisector. Okay, now what? The triangles are congruent, so give me a congruent statement. Triangle AMC is congruent to BMD. So angle A corresponds with B. Angle C corresponds to angle D, and M corresponds to itself. Match up your angles. Okay, and why would be the reason? Angle side, angle congruence theorem. So then our next step is what?
Angle A is congruent to angle B.
Because of See, look at y'all. Y'all remembered it. CTC. Okay. Yeah, Carson.
For the second step, isn't it angle AMC is congruent to angle BMD?
It doesn't matter how you name angles. It matters specifically when you name triangles, though. But technically, yes.
You said AM is congruent to MD too?
Well, AB is bisecting CD. If it were CD is bisecting AB, you would say AM is congruent to MB. But AB is what is splitting CD in half. Good question. Any question on our second proof? We only have one more to go. Are you sure? Yeah, 2 proofs on your skills check. Alright. Example 8. Statements and reasons. givens. We have M is the midpoint of AB, so I'm guessing this should have been M. This is AB. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. So M is the midpoint. Back table. Please quit talking. Lots of givens. 1 is congruent to 2. 3 is congruent to 4. Alright, step 2, what do we got? AM is congruent to MB, and why is that? Definition of midpoint. Now what? Very good. ACM is congruent to BDM, and why is that? Angle, side angle. Then what? AC is congruent to BD, and why is that? Very good. CPCTC. So what did y'all think about those 3 proofs? They're easy. Okay. So all of your proofs should be around 4 steps, and then maybe a 5th step. I think one on the notes last class had 5 steps. Okay. So, is that it? Yes. That is all of your notes. With that being said, we have an hour left of class. Okay. You only need 20 minutes to do that skills check. Okay. So, you won't even need that long. It's 2 proofs, but I'll give you 20 minutes.
That's all? Just 2 proofs?
I can add to it if you want.
No.
Hold on 1 second. So, you have the next we'll go 35 minutes to work. If you missed last class, you might want to take the skills check from last class. Okay? Utilize this time. If you missed last class and never went and looked at videos, or came in for tutorials or asked any questions, you may want to use this time to do that. Okay? If you have headphones, the video's online, you can pull it up on the Student Learning Hub. If you don't have headphones, I have plenty of copies up here of the notes. Okay? Or you have 26 other people in this room that could give you theirs so that you can look at them.